Okay, we want to get some practice calculating the calculating whether a bond is nonpolar, polar, or ionic. And so the first thing I want to review real quick is just that scale again. So if we look at the scale goes from 0, and then it goes, there's two other markers in it. It's 0.5 and 1.7. So if the difference between the electronegativities is between 0 and 0.5, it's going to be nonpolar. If it's from 0.5 to 1.7, it's going to be polar. And if it's greater than 0.7, it's going to be ionic. So let's do one together. I've listed some electronegativity values. Here we have potassium and chlorine. Potassium has a, let's see, electronegativity of 0.8. And then chlorine has an electronegativity of 3. Right? So we take the difference, and when I take the difference, I use the whatever the biggest electronegativity is. In this case, it's 3, and then I subtract the smaller one, and that gives me a difference of 2.2. If I go up to my scale, that would be over here, so it's ionic. What I'd like you to do now is pause the video, see if you can calculate these, and then come back and see if you get it right. Okay, hopefully you paused it. If not, pause it and try, please. Alright, I'm going to assume that you paused it and you tried. Let's continue on. So electronegativities, carbon is 2.5, oxygen is 3.5, so we take the larger one, 3.5, we subtract the 2.5, the difference is 1, it fits within this region here, so it's polar. Right? Hydrogen bromide, hydrogen has an electronegativity of 2.1, bromine has an electronegativity of 2.8, so that's 2.8 minus 2.1, oops, that's a 1, which gives us 0.7, and that again would be polar because 0.7 fits in this region right here. Last but not least, we have a nitrogen bonded to a nitrogen. So nitrogen has electronegativity of 3. If it's bonded to another nitrogen, that's going to be 3 minus 3, which gives us a difference of 0, which fits over here, and so that's a non-polar bond. And it makes sense because if you have two atoms with the exact same electronegativity, then they're going to pull equally on that electron, and you'll have a nice equal sharing. Okay, so that's the end of our notes. Make sure that you complete the WISC chat, or the WISC questions, and we'll see you tomorrow.